So now I'm going to look at this question 19 and 20 and 21. We're going to take a couple of pieces of granitic rock and make some clastic sediment out of it. So here I have actually a diorite and a granodiorite, two granitic type samples, and I'm going to tap these together to make some sediment. So here are the broken pieces of the rock that I just smashed together. So you're going to have to cut out your sedimentary sand size, and you can see that this is going to be, they're on the order of certainly a coarse sand to these bigger pieces over here are gravel, two gravel pieces, and these other ones are more in the sand size range. And then what you need to describe for the lab are they mineral crystals, fragments of minerals, or a mixture of both? So do question 19. What type of sediment is it? Question 20, do that one there. Now when we're going to look at these, we're going to try to sketch 3 grains. And so I'll try to zoom in and have you sketch the 3 grains. And then you want to describe the roundness. And then here is that same Wentworth scale. So looks like most of us are going to be looking at sand size, although we'll look at one of the gravel size pieces. So for Wentworth, you'd want to either put silt, sand, or gravel in, and then make the drawing there. So let's go back to our first sample here. I'd like you to draw this sample right here, and that's a sample that we said was gravel size. You can see it's over here in the gravel size Wentworth scale. The key thing about that sample, it's really a clast, a broken clast, but composed of many smaller grains. And so this was what we would call a lithic, a rock fragment or a lithic. So do that one there. And then over here I see this quartz grain right here. So if I can pull it out there, yeah. So see that quartz grain? So I want you to draw that. You can see it's not very round at all. Can you make out any sharp edges to it? All right, so that's our quartz grain right there. For our third, so here's another quartz grain. So you can pick that grain there. You can see it has kind of a jagged, angular edges. So I've zoomed in a little bit more, and maybe we can draw in some of these grains that are over here. And they look to be like little biotite, maybe a hornblende over here. And so when we look at the size, they're in the medium sand, so they're definitely sand size. Try to draw some of the shapes of these dark minerals for one of your sketches. So we're going to do, for our sketches, we want to do certainly this lithic, this larger lithic fragment. I mentioned that there's several quartz grains in here. See the white milky quartz? And then you also want to do some of these biotites. So that'd be our 3 grains. Here's kind of a vitreous biotite down over here. So draw those, and again, you're showing that the shapes of these are fairly angular. All right, so continuing on, answer questions 22 based on this satellite image for the Mississippi River Delta. Activity 1.4 deals with Mount Rainier and different portions of Mount Rainier, the volcano, what the sediment is looking like. So in fact, I'm going to go to Google Earth and show you. All right, so here I have Google Earth open, and we're going to look at Mount Rainier, which is, I think this volcano here. We'll zoom in. And so there is Mount Rainier. So here, for Mount Rainier, this outcrop's occurring around 6,600 feet above sea level, and this is what you expect to see. So remember, this is a stratovolcano, and so let's zoom into that area. The area they're talking about is on this skyline trail right here. So you see, this is the outcrop of the andesite, and you can see it's weathering, and you have this really brecciated talus slope here. And so that's where this sample, this first outcrop's coming from. Mount Rainier outcrop at 6,600 feet elevation, and that's right around this region right in here. And so this is debris. And so yeah, here's that skyline trail where they're coming up here. The second part is you're moving a little bit farther down at about 5,600 feet elevation on the volcano. So if we zoom out a little bit, so you can see there's this river that comes down here. And so the second outcrop or position where they're taking rocks is down in here. You can see some of they're still pretty jagged down in here. So that's where they're getting that second sampling of rocks. And the third sample, now they're in this Nisqually River Valley near Longmire. And so let's take a look at that one there. Yeah, in fact, this is the little town of Longmire Road. So they're getting that from the river down here, right? So you can see the cobbles, yes, all those cobbles. Here's the water going through there. So that would be the third picture here. And then finally, over by the Alder Delta near Elbe, that's this last picture here. So we'll just follow this stream down to, there's a reservoir over here. There it is. So this is the town of Elbe right here. and then, yeah, this is LV. And so this is a little delta where they're taking that last sediment sample from. So if we kind of zoom out again here, we'll see that the initial sample is from up high in the volcano. Second one's in this valley down here. Third one's down here near in Longmire down here. And then finally at the delta. So it's showing distance traveled from the volcano. So you can answer those questions now that you have an idea of where the sediment is coming from. And then again, you want to use your Wentworth scale to determine the size of the different particles in these pictures. They're rounding, they're sorting. Again, what type of classic sediment is it? And then and if it were to make a rock, for example, this first one, if that were to be lithified, that's going to make a breccia. You got these angular fragments here, right? Now, one thing for this lab, especially when we start identifying the unknown rocks in activity 1.7, I want you to determine what environment did the rock form in. For example, I mentioned breccia. So breccias are usually going to be at the base of a cliff, you know, those talus slopes, right? Or maybe breccias in glacial deposits. One thing about glacial deposits, the cobbles and boulders will be scratched because they're grinding up against each other. And then in river systems, you might see mostly conglomerates, right? Once you get to a delta, we're going to see the finer sands and silts. And then out in the ocean, so obviously the sands are going to be on the shorelines, right? Sandstones, maybe conglomerates due to the rivers bringing those in here. You can see in arid environments, we're going to have evaporites like rock gypsum, rock halite, maybe some dolostone, dolomite, travertine at hot springs. So those are the environments that I'm thinking about there. And so remember, all these up here are terrigenous, meaning they're formed on land. And then the sediment that gets eroded and deposited in the ocean, if it's siliciclastic, it's called terrigenous. But also we have a lot of biogenous sediment out here, like these calcareous plankton oozes. They're either making limestones or chert, here's siliceous planktonic oozes. Remember the oolitic limestones, those are only forming in warm tropical waters, and they're by the oscillation of either currents or waves to make these as an inorganic sediment. So here there's really no organism that's making a shell, it's just a chemical precipitate. So anyways, I talk about all this in my video lecture, so you can take a look at that. So you want to refer back to this figure 8 for trying to determine the depositional environment. This next part is about lithification. You can read about this. I also talk quite a bit about this in my video lectures. Remember, I focus it in 3 steps. There's burial, compaction, cementation. And now for activity 1.5, I give you, if you want to try to identify these, I give you a list of minerals and how to identify them in these sand samples. And so in this case, we have some ooids, so these are calcium carbonates. So this is a chemical sediment, a chemical precipitate, again occurring in warm, tropical, shallow waters. So again, using the scales here, 0 to 1 millimeter, do their Wentworth scale, right? You could also remember, I give you this Wentworth scale in the lab. You can print it, cut it out. I also gave it to you in the minerals lab as well, so you'll have another copy of that as well. So you go through all 6 questions here for each of these sediment types. And then once you've completed that, you can answer the questions 29 through 35 based on these samples. And then for activity 1.6, there is these pictures of rocks that I have here on this next page here. And I put some notes on here. For example, this sample 3, it has halite. And this is a rock salt. And rock salt is an evaporite. So this is going to be a chemical rock there. So that'll kind of help you in terms of whether it's siliciclastic, biochemical, or chemical. You would say chemical for the rock salt. Obviously, the composition of rock 3 is halite. And then in terms of its scale, these pictures are to scale. I mean, it's 1 to 1. It's like having a hand sample. So again, you would use your Wentworth scale. And these are pretty big. These are on the order of 1 centimeter. So they're definitely in the gravel size range. And then for rounding, they're not rounded at all. They're crystalline. In fact, you might want to say something about the texture here being crystalline. Remember, I had those textural terms back over here when we looked at this figure 7 here. So crystalline, you want to say that for the rock salt. And then sorting, I guess it's pretty well sorted because they're all about the same size. And the environment, well, obviously that would be back to figure 8 over here. And the environment must be somewhere where we're seeing evaporating, dry lakes in the desert, for example, or maybe in a lagoon setting. Yeah, you can highlight over here. So it could be either of those settings for depositional environment. And then name the rock. In this case, it's rock salt. So that's what you want to do for all these samples. I'll give you some clues here with these texts, with this notes that I put in there. So you'll finish that table up for these rocks here. And then finally, for activity 1.7, you're going to identify these unknown rocks in the next video. And you can see here I have some pictures of how I want you to describe these rocks. So these are the siliciclastic rocks. You'll want to read through these and understand what this word, in fact, there's an important word called fissile here. I want you to know what this fissile means. Fissile means it's in these sheets. And note that one of our samples up here is fissile. See the sheets there? So that gives you a clue as to what this rock is. Even though this rock has some fossils in it, some impressions of ferns it looks like, it was probably in a really quiet water environment where mud was collecting, the fern leaves were near this lagoon, for example, and then they would sink to the bottom of this lagoon or this swamp or bog, and then the fine mud would bury it. But it would bury it in this fissile fashion, so you can get an idea of what rock name I'd want you to use for that. And then for the chemical rocks, again, I discuss all this in my video lectures. Make sure you read through that to figure out about what these foraminifera are, the zooplankton, the phytoplankton. So you want to understand what all those are. Coquina and phosphorus limestone, 2 carbonate rocks. They're mostly calcium carbonate, so they're a type of limestone actually. But the fossiliferous limestone, lots of fossils, but they're well cemented and there's very little porosity. Whereas the coquina is not as well cemented and it's more porous. And again, for chert and diatomite, read about those. And then you can use this table 1 for siliciclastic rocks to name them, and table 2 for the chemical rocks to name the different chemical rocks. Remember, these also include the biochemical limestones and chert. And then for the last part, activity 1.7, you'll want to identify the unknown samples in the next video. And here I give you an example, figure 11, and that's this picture up here. So the first thing they're asking is, what is it? Bioclastics, chemical, so this is a siliciclastic rock. And I can tell because it's made up of broken, primarily feldspar grains. This is pink feldspar, that orthoclase or plagioclase feldspar, K-feldspar. And if you look at the sizes here, they're huge, so they're gravel size. So here I say that it's siliciclastic. It's mostly this angular pink feldspar. Looks like there's some 10% quartz in there. And the quartz would be these lighter color grains over here, right? So there's a little bit of quartz in there. And then there's this green matrix or mud that's cemented. Yeah, here's the quartz grains up in here. So kind of clearish. And they look green because quartz is clear and it's picking up some of this green from the matrix there, the mud matrix. And then gravel class, angular, poorly sorted. So you want to say something about sorting, how the rounding, and we got that matrix in there. So mud and gravel mixed together. So it's really poorly sorted. And this is probably terrestrial and is a good example of something on a talus slope at a base of a cliff. So you can see back here on figure 8 where we're looking at these depositional environments. That's where we're looking at this kind of cliff deposit. So that's probably forming in an area like this. So you would actually call this a very immature sediment. Immature. It hasn't been worked on. It's very fresh in the environment. It hasn't been rounded. Nothing of that has happened so far. And then the rock name is a breccia. So that's what we want to do for activity 1.7, and you'll see the sedimentary rock samples in the next video.